What is probability? Probability is concerned with predicting chances, especially the occurrence of an event. There are three types of probability. We have the classical probability, empirical probability, and subjective probability. Classical probability assumes all outcomes in a sample space are equally likely to occur. For example, rolling a die. Rolling a single die. It has a sample space of 6. That is an example of classical probability, meaning we just assume. We don't conduct experiment, we don't conduct observation. The opposite of classical probability is the empirical probability, wherein it relies only on actual observation to determine the likelihood of outcomes. For example, rolling a die 6,000 times. That means you have to conduct the experiment of rolling a die 6,000 times, and you are going to record the outcomes. And we have the subjective probability. When we are talking about subjective probability uses probability value, which based on an educated guess. For example, they have 90% chance of winning the game, or the class has 99% of passing the exam. Those are examples of subjective probability, meaning you don't base on actual observation, which is merely a guess. We have counting techniques, but before that, we need to be familiar with this terms. Experiment. Experiment is any probability activity. Probability experiment is this the same? The same is the chance process that leads to well-defined results called outcomes. We have outcomes. It is the result of a single trial of a probability experiment. So the tree diagram. Tree diagram is the graphic organizer that makes use of branching and connecting lines to represent a certain relationship between events. Example, okay. What if we are asked to find the sample space of 2 coins? Sample space into tossing 2 coins. This is the first coin. A single coin has the sample space of head and tail. Then the second coin, head and tail also. So if the 2 coins are tossed simultaneously, it has the result of head, tail, head, and tail. So that's the sample space of in tossing 2 coins. Sample space is the set of all possible outcomes of a probability experiment. An event consists of a set of outcomes of a probability experiment. Sample space of a single die. When we talk about dice, we think of a cube. It has 6 faces. So we have 1, 2, 3, 4, 5, 6. Okay, so the sample space is 6. 1, 2, 3, 4, 5, 6. What if we are asked to find the sample space of 2 dice? So when we are going to roll 2 dice, it probably we can get 1 and 1, just like that. 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6. This could happen. This could occur if you are going to toss 2 dice at a time. It has also a possibility that we can get 2 and 1, or 2 and 2, and so on. So when we are going to toss 2 dice, we get 36 sample space. 36. So we have this pairs 1 and 1, 1 and 2, all the way to 6 and 6. So sample space of a single deck of cards. So since you are familiar with the deck of cards, it has 52 cards, disregarding the jokers. Okay. So it has 52 sample space. Sample space of 10 coins tossed simultaneously. So if you're going to use the tree diagram, this could be lengthy and tedious to construct or to find the sample space. All you have to do is to list down the number of times we are going to toss a coin. So it had, here we have 10 coins. The number of times is just once. That means we're going to toss 10 coins simultaneously, meaning at the same time. So we have how many coins? 10 coins. And the sample space of each coin is 2, since it has only head and tail as the sample space. So all you have to do is to multiply them. So 2 times 2 all the way to 10 is equal to 2 raised to 10, and it's equal to 1024. Find the sample space of 3 dice rolled at the same time. Okay, we have here the number of dice rolled. We have 3 number of dice rolled, and the sample space of each die is 6. So all we have to do is to multiply this 6 3 times. That means 6 times 6 times 6 is equal to 6 cubed, and this we will get 260.